Okay. All right, in 6.2, we're going to be solving trig equations. So if you can do algebra, then you can do this, okay? Our solutions are going to come from our exact value sheet. So this is why we have to have this in front of us, because we're going to find all of our answers on this sheet of paper. And we're going to be solving two types of trig equations. We're going to be solving a linear equation, and we're going to be solving a quadratic equation, okay? And there's two methods to do it. When you're solving a linear equation, you'll have a trig function that's to the first power. And what you do is you solve the equation for the trig function, and then you're looking for every angle that will solve this problem, whatever angle you can put in this equation. So if you solve this equation over the interval from 0 to 360, this is telling you that they want their answer in degrees. If they say from 0 to 2 pi, then obviously they want their answer in radian measure. So be aware of whether it says 0 to 360 or 0 to 2 pi. All right, notice it's always going to have a bracket at the 0, and it's always going to have a parentheses on the 360 or the 2 pi. Do y'all remember with interval notation what the bracket and parentheses mean? Like included and not included? So you could include 0 as one of your answers if it needs to be, but you cannot include 360, you cannot include 2 pi, which means when you're looking at your exact value sheet, you look everywhere except that last row right there. Nothing from that last row could be one of your answers, okay? All right, so let's solve this equation. All right, you need to get tangent by itself, so you move square root of 3 to the other side. So 3 tangent theta is going to equal square root of 3. Then divide both sides by 3. And you get the tangent of theta is the square root of 3 over 3. Then all you have to do is look down your tangent column and find every angle that's got square root of 3 over 3, and you're looking at the degree side. So tangent, let's see, looks like we're going to have 30 degrees on our exact value sheet, and what's another one? 210. Thank you. Y'all are quicker than I am. And that's it. Those are our two solutions. It's just that easy. Okay, let's look at this one. Yeah. No, interval notation only tells you where to look. You just write your 2 answers, or 3 answers, or 4 answers, or 5 answers, or no answers. You always just list them out, okay? All right, solve this equation. 2 secant of x plus 1 is equal to the secant of x plus 3 from 0 to 360. All right, you've got to get your secants on the same side of the equation, just like you would if anything else. So you're going to subtract secant to the other side. Hold on, my pencil is okay, there it is. All right, subtract secant to the other side. All right, 2 secant minus 1 secant leaves you with 1 secant plus 1 is equal to 3. Subtract your 1 and you get the secant of x is equal to 2. So you look down your secant column and you find every angle that has a secant of 2, and I see 60 degrees and 300. Okay, not too bad, huh? Do what? What just happened? Where?
The first.
I moved the secant over to be with that secant. So I subtracted secant to the other side of the equation. 2 minus 1 gave me 1. So I still have secant plus 1 is equal to 3. Then I subtracted 1 to get 2. And I got the secant of x is equal to 2. Then I looked down my secant column and found my angles. I'm not sure where I'm losing you. Okay, well then let's go on. These are linear equations. Okay, every time you have a linear equation, you'll have one trig function, solve for that trig function. Right, the next page has to do with the quadratic equation. So how do you tell if you have a quadratic instead of a linear? Well, for quadratic, you'll either have trig functions multiplied, like these two are right here, or your trig function will be to a power. So if it's quadratic, then you'll have trig functions multiplied, IED, multiplied, or your trig function will have a power. Other than one, a power like squared or cubed or anything higher than that. This indicates that it's quadratic. If it is quadratic, the steps you have to go through, instead of solving for the trig function first, what you have to do is you have to first set your entire equation equal to 0. So set it equal to 0. Step 2, factor, everybody's favorite. Then step 3 would be to set your factors equal to 0 and solve those. All right, so this is for quadratic. All right, so let's look at this problem right here. Cosine times cotangent is equal to negative cosine, and we're looking from 0 to 360. This one is quadratic because these are multiplied together. So step 1 is to get it equal to 0. So I'm going to move the cosine to the other side. So this gives me cosine theta times cotangent plus cosine theta equals to 0. Step 1, equal to 0. Step 2, look for a way to factor this thing. What I see is a common factor. Don't forget about looking for common factors. Do you see that this term has a cosine and this term has a cosine? That's a common factor. So pull out the common factor. So when you pull out that cosine, in the first term you have a cotangent plus, what's left from the second term when you factor out the cosine? 1 equals 0. So you've got these two factors. So now step 3, you set the two factors equal to 0. Cosine theta equals 0. The second one, cotangent theta plus 1 is equal to 0. This one is already solved. This one, just subtract 1. So cotangent theta is negative 1. And then you're going to have two columns to look down. Look down both columns and find the angle first, whose cosine is 0, and they said write it in degrees. So it looks like for this one I have 90 degrees and 270. And for this one, cotangent of negative 1, I've got 135 degrees and 315 degrees. So you've got 4 answers for this one. So any question?
Kind of got lost in the steps. Like on the common factor before. You took out the cosine and tangent.
Right.
What happened to the other tangent? I mean, the other cosine and tangent. Like with two of them at the top, cosine.
I've got a cosine times a cotangent, and then I've got a plus a cosine. It's a common factor, so I'm pulling it out of both of them. You're like undistributing. Think about distribute backwards. All right, when I get to this step, if I want to check what I did, I've got to be able to distribute and get back to what I had. So if you distribute, you have cosine times cotangent to get that, and cosine times 1 gives you this cosine. I mean, I'm pulling it out. Okay. All right, anything else? Okay. All right, then let's look at the next one. Solve. 3 sine squared minus sine minus 2 is equal to 0 over the interval from 0 to 2 pi. All right, finally we're going to have to write our answer in radians. This one is quadratic because you have the sine squared. Step 1 is to put it equal to 0. It's already equal to 0. So step 2 is factor. There is no common factor. So you're going to have to try to unfoil it. So if y'all use like whatever bottoms up or whatever y'all use for factoring is what you're going to have to do here. But I just do it trial and error. So 3 sine squared, I'm going to need 3 sine of x times the sine of x. Then for my 2 down here, the only factors of 2 are 2 and 1. And I think when I factored this yesterday, I had a 2 there and a 1 there, and I think this was a minus and this is a plus. Let's see, 2 minus 3 gave me negative 1. All right, I believe that's the way it factors. Step 3 is to set my factors equal to 0. Three sine x plus 2 is equal to 0. Sine x minus 1 is equal to 0. This gives me the sine of x equal to 1. This one, 3 sine x is negative 2, and if I divide by 3, I get sine x is negative 2/3. Okay, questions so far? All right, I've got to look at my sine column for these two numbers. Negative 2/3 is a problem because it's not there. So what we're going to do is just ignore this because all of our answers have got to come from our exact value sheet. If it's not on there, there's no solution to this one. All right, so all we have to look for is in the sine column, look for our ones, make sure you write it in radian measure. So our angle x, sine is equal to 1, is going to be pi over 2. And I believe that's it. And there's only one answer to this problem. Question about that one? Okay, then the last one they have on here. 2 tangent squared sine minus tangent squared is equal to 0 over 0 to 2 pi. Again, radian measure. Step 1, this is quadratic because they are two trig functions multiplied, and this is to the second power, so it's quadratic. So you're looking to put it equal to 0. It's already there. Step 2 would be to factor. What do y'all see as far as factoring is concerned here? Common factor, and I see what tangent squared. So I'm going to take out tangent squared. So I'm doing like I did with that other one. I'm taking tangent squared from here. So that leaves me with 2 sine theta minus, when you take the tangent squared from this one, you have a 1 equal to 0. Okay, it's like the other one. It's a common factor. Then step 3 is set your factors equal to 0. Tangent squared theta is equal to 0. 2 sine theta minus 1 is equal to 0. When I solve this one, 2 sine theta is 1. Jumping ahead of myself. Divide by 2. Sine theta is 1/2. On this one, to get the tangent, I have to use the square root property. So technically, I'm looking at the tangent of theta equal to plus or minus the square root of 0. But the square root of 0 is just 0. So, and 0 is not either positive or negative. So I'm just looking for the tangent of theta equal to 0. So looking in two columns, where the tangent is 0, I'm going to have 0 radians, and I'm going to have pi. And it's also down here, if you'll look, it's also down here at 2 pi, but I don't use this one because it's not included, so don't look down there. And then for the sine theta equal 1/2, what do I have, pi over 6? And do I have and 5, 5, or 6. And I've got those 4 answers. Question? Any questions? All right, the last page just gives us the rules, and I'm going to do this, and I want to work one more problem because I want to just show you one more thing. But the rules that we've gone over are right here. You have to decide whether your equation is going to be linear or whether it is quadratic. And again, if it's quadratic, you'll have trig function to a power, or you'll have trig functions multiplied. If only one trig function is present, solve the equation for that trig function. That means it was linear. So this is the linear step. If more than one trig function is present, rearrange the equation so that one side equals 0. Then try to factor and set each factor equal to 0 to solve it. In this step, this is what you do if it is quadratic. Okay? And the problem that I wanted to work is this one. This is number 33 out of your book. And it's similar to something we've done. I just wanted to make sure that you don't forget this. So secant squared theta times tangent is equal to 2 tangent theta, and they want us to look from 0 to 360 degrees. All right, what type of equation is this one? Quadratic. So what do I need to do? Equal to 0. So move the 2 tangent. Secant squared theta times tangent minus 2 tangent is equal to 0. All right, so that was step 1. Step 2 would be to factor it. What do you see for factoring? Tangent is a common factor, so there's a tangent. So pull out your tangent. You're left with secant squared minus 2. That's gone, that's gone. We put it right there. Secant squared minus 2 is equal to 0. Step 3, your factors equal to 0. So tangent theta is equal to 0. Secant squared minus 2 is equal to 0. This one is already solved. For this one, move your 2. Secant squared theta is 2. When I take the square root of this side, I have secant theta is equal to what is over here? Plus or minus the square root of 2. You have to look for both of these in the secant column. You have to look for positive square root of 2 and negative square root of 2. So you've got 2 places to look in your degree column. You're looking in your tangent equal to 0. So I have 0 degrees and 180 degrees. And in my secant column, plus and minus the square root of 2. 45, 135 for negative square root of 2. Another negative square root of 2 is 225, and a positive square root of 2 is 315. So I have 1, 2, 3, 4, 5, 6 answers here. And if you had not done plus or minus, you would have been missing some of your answers. Okay? All right. Do you have other questions?
Yeah, you told me work from now.
Let me finish with the class first, please. Okay? All right, I want y'all to look at these, see if you have any questions about any of these. Some of these are crossed out, so I wouldn't ask you these that are crossed out. But do you have any questions about any of these that are not crossed out? All of these are crossed out, those are crossed out. Exactly. These are already factored, don't foil it out. Just set that equal to 0, that equal to 0, and yeah, they've done the hard part for you. Yeah, I'm glad you asked about that one. Do y'all see anything else? Okay, then that is it for chapter 6.